Lisa when. Okay, so let's start with you said with what? With the recaps. Yeah. Okay. So which function do you know? Or how many functions do you know? Functions, are they not more than that? No. Are they not more than that? So we have a straight line function, right? Which it is simple, right? Which is given by what? By y equals to mx plus c, right? Which a may be element? Gradient. And then c? Y. The y-intercept, right? So if the c maybe is 5, so it means that our graph will be cutting at 5, right? Something like that. And then if our m is negative, right? If m is negative, it means that our function is somewhat in this way, right? It will be moving from left to right like that. But if our m is positive, how is our function? It will be moving somewhere in this manner like that, right? And you know how to find the gradient, right? So we can just move on from the straight line, right? Okay. Which are the function?
Parabola.
Parabola. How is the parabola? So parabola is called the what? Quadratic function, right? Or we can call it the parabola. How many forms of the parabola do you know? Because like parabola comes in many forms, right? So the first form of a parabola, it is given by what? The first form. So the first form, it is given by y is equals to ax squared plus bx plus c, right? Which a is the what? Not really the gradient. It is the what? It is the what? A, it is the what? So A tells us how our function is, right? So it's either it is concave up or concave down, right? So if our A is greater than 0, if it is positive, right? So it means that our function will be smiling, right? And then we have a minimum point. So this is concave up. So we have a minimum. So what is the minimum point actually?
Turning point.
Yeah, it is the turning point, right? But we're not talking about the minimum, we're talking about the y value of the turning point. Right? So this is the y value of the turning point. Y value of the turning point. Right? So if again it is like this, right? We know that our quadratic function is the what? Is the domain and the range. Right? So our range now, since the range, we talk about the what? The y value, right? And since we said this function have the what? The minimum point. So it means that our range would be y is the element of real numbers, but our y should be greater or equals to the y value of the turning point. Right? Because if you check all the y values that are defined in this function, right? Where's that thing? Where's that thing? Okay. So all the y values that are included in this function, right? They'll be either be equals to this value or they'll be greater than this value. Right? Making sense? But now if our a is less than 0, what do you know if our a is less than 0? You know that our graph will be concave down, right? And we have the maximum value. Now we have the what? The maximum, right? And our range now will be what? The y is the element of real numbers, but our y now should be less or equals to the y value of the turning point, right? But the domain of either of these functions is just x is the element of real numbers, right? So that would be our domain. So here we showed the first form of the parabola, right? So in this first form, there are ways that you can find things that you need maybe to plot the function, right? So the first thing we need to know the value of a. So we said if a is greater than 0, this is what happens. If it is less than 0, that is what happens, right? So now, what about the value of C? What does it show, the value of C? Maybe go 2. Sure. So the value of C now, it is the y-intercept as well, right? So if maybe our y is maybe -2, so it means that our function will be cutting at -2, something like that, right? That is the value of C, right? And also we need the x-intercept, right? Where the graph is cutting, right? We call them the roots as well. So in the minions, how do you find that?
Value of x.
The x-intercept. We let y is equals to 0, right? And then we can solve for x by factorizing or any other method that we can use, right? So there'll be only one last thing that will be left, it is the turning point. So how do you find the turning points in this situation?
I see like negative b.
Yeah. So to find the x value of the turning point, it is given by minus b over 2a, right? So after finding the x value of the turning point, it means that our y value of the turning point, how do you find that? We can just substitute the x, right? The x value, and then you can find that. So this is the first form of the quadratic function, right? So let's take a look at the second form. Which other form do you know? So that one, it is called the standard form, right? The one that you're from doing. The standard form. Let's just. And we also have the turning point form. Do you know the turning point form? Okay. So the turning point form, it is given by f at x is equals to a x minus p squared plus q, right? So this is the turning point form. So again, on the turning point form, a just represents what you talked about, right? And to find the turning point, so it means that our x value of the turning point will be x is equals to the opposite of whatsoever that is inside here, right? So if here we're having -2, it means that our x value of the turning point it will be 2. If it is +5, then it will be -5, right? But the y value of the turning point, it is just represented by q, right? So it means that the y value of the turning point is equals to q. No matter how it is our y value of the turning point. And to find the x-intercepts, again, we let y is equals to 0, right? To find the x-intercept, to find the y-intercept, to let x is equals to 0, and then we can solve, right? Simple, right? Okay. And then the last, so this one is called the turning point form. The turning point form, right? And then lastly, we have the root form. But the root form is just more of the same as the what? Is the standard form. So how is our root form? Our root form is given by y is equals to a x minus x1 x minus x2. So it's more like it's in a factorized form, right? So to find the x-intercepts, we just take the opposite of that and the opposite of that. That will be our x values, right? Our x-intercepts, right? And then to find our y-intercepts now, just for an example, maybe if we're having y is equals to maybe 2 here, x minus 3, x plus 5, right? Something like that. So if we want to find the x-intercepts, we said we just take the opposite of that, right? So it means that our x value, our first x value to be x is equals to 3, x is equals to -5, right? So to find the x value of the turning point, so this we say is equals to x1 plus x2 divided by 2, right? So here our first x, it is what? 3, right? Plus -5. all over 2. So this becomes negative 2 over 2, which is just negative 1. So x value of the turning point, it will be negative 1. So to find our y value, it will be simply just substituting on the value of x, right? And then we find our y value of the turning point. Making sense? Okay. And then to find the y-intercept, still we let x is equal to 0. And the a still represents the concavity of the function. It's either concave up or concave down, right? Yes. And then also, this function, the parabola, it also has something else that is called the axis of symmetry. Do you know what is the axis of symmetry? What is it? What is the axis of symmetry? So the axis of symmetry, it is the line that cuts the function into 2 equal parts, right? So if we take a look at the parabola, maybe let's try to plot it nicely. Yeah, I'm not good at this. Right. So maybe this is our function, cutting it there, and then cutting there. So if here maybe we're having negative 2, and here we're having 6, right? So these are x-intercepts, right? So the axis of symmetry, it should be a line that will cut this function into 2 equal parts. So this half should be equal to this half, right? So this equation of this, it is given by x is equals to the x value of the turning point. That is our axis of symmetry. So if you take a look here at this thing, what is our x value of the turning point? Yes, but I should do like how we can find the x value of the. Yes, so we add these two and divide, right? So it means that our x value of the turning point becomes what? 6 plus negative 2 divided by 2, right? Right. So the final answer will be 2. So this value, it is 2. So what will be our axis of symmetry? Our axis of symmetry is simply x is equals to 2. That will be our axis of symmetry. Right? Making sense, right? Yeah. So what you have to know about the parabola, it is simply, because sometimes they can trick you in this manner. Let me try to draw as much better as I can. So imagine if you are given this function, and then you are given something like, right. So they tell you that there is a parallel line here. There is a line that is parallel to the x-axis like that, right? And then they tell you that this axis of symmetry, it is x is equals to 1, right? So this x value, it is 1, right? And then they tell you that there's another point here. Maybe this is point D. And there's another point here, which is point F, right? So these are the tricks that you should always remember when you're dealing with a parabola, right? They can tell you that D, it is maybe negative 1. Maybe this is not visible. Negative 1 and 6, right? Like that. And then they say, what are the coordinates of F? What can you say? What can you say? If they ask you about the coordinates of F, what can you say?
Can't you use this?
So we sort of use that. In what sense? Remember, this axis of symmetry, what does it do really? It cuts the function into 2 parts that are what? That are equal, right? As long as those values, they have the same y value, right? Or as long as those points they're in a parallel line to this one. Can you see that? So you can see that this point here, right? Maybe if they say this is 3 and 0, right? The y value, we know that it is 0, right? So it means that these points they're in what? Straight line. So they will be divided equally by the what? By the axis of symmetry, right? Sorry, this is negative 3. So how many steps are we moving from negative 3 to the axis of symmetry, which x is 1? How many steps are we moving from here to 1?
To 1.
Yeah.
2.
No. This is negative 3.
Oh, negative 3.
Yeah. So from negative 3 to 1, how many steps are we moving? 4 steps, right? Yeah. So we are moving 4 steps to get to 1. So how many steps are we moving also from this point to this point?
From this one to this one.
From this one to this one. It also should be 4 steps, right? So here we're going to say 1 plus 4, which this one will be 5, right? Making sense? So here also we know that this point and this point, they are what? They are sharing the same y value. Why? Because this line is parallel to this line, right? Okay. So the y value here, it will be 6, right? But what about the x value now? So the x value now, we check how many steps did you move from this point to the axis of symmetry. This x is negative 1 and this x is 1. So how many steps did you move here? 2. So how many steps should you move from here to this point? 2 as well, right? So from 1, if we add 2 steps, what will be this? 3. As simple as that. Can you see that? So always remember that if they tell you that this line is parallel to the x-axis, just know that somehow they'll ask you a question based on the axis of symmetry, like if this point is what, how many steps are you moving that way, right? As long as these lines, they're sharing the y value, it means that the x value to be determined by the what? By the axis of symmetry, right? So if this point here, it is 0 and 7, what would be the point here?
I found 1.
Yes, the axis of symmetry is 1, and this is 0 and 7.
I found 2.
2 and 7. Can you see that? As simple as that. So that is one last trick about this function. Right. Are you able to find the equations of a parabola if you are given a function? Or maybe you can try to do that when you are... Well, maybe let me just explain that. Okay. So also a parabola, it is... sometimes you may be given a function.
After this, can you do how to find the equation of the axis of symmetry?
Of the parabola? Because this one is only has one axis of symmetry. That one that we are from doing. That one is the hyperbola. It has 2 axes of symmetry, right? Yes. So, now how to find the equation of a parabola, right? Of a parabola. So, how to find the equation of a parabola, right? It's a bit tricky, but it's actually simple, right? So, according to methods that I know, I think there are 3 ways in which you can be given a function to find the equation, right? So, the first way, it is the simple way, which you'll be given x-intercept and an additional point. How do I mean by that? I'm trying to say that maybe I'm given a function like that, right? And I'm given something like this is negative 3 and 0. This is 5 and 0. And maybe I'm given this point, which we can call it 3 and 4. Right? So here we're given what? Axis of symmetry. No, not axis of symmetry. We're given the x-intercept and an additional point. Right. So what do we use if we are given in this form? We use the root form to find the equation, right? So here we are going to say y is equals to a x minus x1, x minus x2, right? So this value, it will come here as the opposite, right? So this becomes y is equal to a x plus 3, correct? And then x minus 5, correct? So now we can use this additional point to find the value of a, right? So what is our y value there? 4, right? Becomes a, and then 3 plus 3, and then 3 minus 5. So 4 becomes a, and then 6 multiplied by negative 2. So 4 becomes negative 12a. So a becomes negative 1 over 3. Correct. So as simple as that. And then we can re-put that into the function, right? So this becomes negative 1 over 3, x plus 3, x minus 5. So y becomes negative 1 over 3, x squared minus 2x minus 15, correct? I think so. So y becomes negative 1 over 3 x squared plus 2 over 3x and then plus 5. Something like that. So that would be our equation. We found the equation. So this is when you're having what? The x-intercepts and an additional point, right? So let's move to the other way that they can test you this. So sometimes you can also have the turning point and an additional point, right? So let's see how we can deal with this one. Yo, excuse my throw. So maybe we're having something like this. So this is negative 2, negative 9 maybe, right? And here we're having 3 and 4 as well, right? So we're having only the turning point and an additional point, right? So it will be understandable to use the turning point form, right? So the turning point says y is equal to what? A x minus p squared plus q, right? So y becomes a, and then here, what is our x value of the turning point?
Negative 2.
But here we are going to place it as what?
Positive 2.
Positive 2, right? And then negative 9, just the way it is, right? Now we are going to substitute another point to find the what?
A.
To find the value of a, correct. So what is our y value there?
4.
4 is equal to a, and that is 3 plus 2 squared minus 9. You can bring 9 this side. So our 13 becomes a, and here what do we have? 25, right? So a becomes 13 over 25, something like that,
Yeah.
right? And then from then you can take this and substitute at the value of a, right? So it depends on how they want the equation to be, right? If they want you to just leave it in the turning point form, so it means that it will just be y is equal to 13 over 25, and then x plus 2 squared minus 9. But if they want you to expand that, you can expand that, right? So this is simple. It's simple. Are you sure?
Hey.
Okay, so the last way that I know, maybe there may be some other ways, right? So this is when you are given the y-intercept and 2 additional points, right? How do I mean that? I mean maybe you are given this function of yours like that, right? So here it is 0 and 5, right? And here maybe negative 6 and 2, right? And maybe we are given also negative 4, negative 4 and negative 3 maybe, right? So you can see that we're having the y-intercept and 2 additional points, right?
Yes.
So here now we use the standard form. We use the standard form. So what is the standard form? It says y is equals to ax squared plus bx plus c, right? So here we're going to say, first thing, we substitute the what? The y, because this represents the value of what? Of c, right? So y becomes ax squared plus bx plus 5, right? So now we are having 2 additional points. So let's substitute these points one by one, right? So this one is saying negative 6 and 2. So y it is 2 is equals to a, and then negative 6, right? Squared plus b, negative 6 plus 5, right? So maybe we can take 5 this side, so it will be what? Negative 3, right? Becomes 36a minus 6b. Making sense, right? So this, you can say this is our, or maybe let's take this side and then this side, right? So our 6b becomes 36a plus 3. We can divide throughout by 6. So our b becomes 6a plus half. So this can be our equation number 1, right? And then you can do the same thing with this remaining point that we didn't talk about, right? So again, what is our y value then? Negative 3, right? Becomes a, and then negative 4 squared plus b, negative 4 plus 5. So again,
Whoa.
yeah. So again, take this side, so this becomes what? Negative 8, right? Becomes 16a, correct? Minus 4b. This side, so 4b becomes 16a plus 8. Dividing by 4, our b becomes 4a plus 2. So now we can see that we're having 2 equations that can be solved simultaneously, so, right? So this is our equation 2. So equation 1 in 2, right? So let's see how we can deal with this there. So the first equation is saying 6a plus half will be equivalent to what? 4a plus 2. Take this side, this side. So 2a becomes 3 over 2, right? And then dividing by 2. So a becomes what? If you divide by 2? 3 over 4, right? So after finding a, you can find the value of b. And then from then, we're having our equation, right? So these are the 3 methods that I know that you can use to find what? The equation of a parabola. So is there anything else that I missed on the parabola? If there's anything, speak now or forever hold your peace. No, okay? So let's move maybe to hyperbola. Okay. Or maybe should we attempt the questions on parabolas first and then we can move to hyperbolas? Okay. Okay. Should we attempt this one? Yeah. Okay. So how many graphs can you see there?
2.
The 2 functions waving the hyperbola, right? I mean the parabola. So the parabola, it is given by that, and you can see that it is in the what? Turning point form, right? And then you're having a straight line, right? So we're told that A is the turning point of F, right? And what else? Okay. So the axis of symmetry of F intersects the x-axis at E. Okay? And the line G at this point, right? So what are they trying to tell you? You know that this is the what? The axis of symmetry, right? So the x value, if they give you the straight line like this, the vertical line, right? So this is a vertical line. What do you know about a vertical line? A vertical line will always share the same x value. Does that make sense, or should I repeat that?
Only shares the x value.
Yes. So it means that the x value here, it is the same x value there. It is also the same x value there. So once we can know the axis of symmetry, it means that we also know the value of m. Correct, right? So that's what we have to know about functions. Always, if you're having vertical lines, just know that they share the what? The same x value. If you're having horizontal line, they share the what?
Same y value.
The same y value, right? Always keep that in mind, right? So we're told that C is the y-intercept of F and G. So they're sharing the same y-intercept, right? Correct. Okay, so let's move on to the questions. Let's see. What do they have? Okay, write down the coordinates of A. The coordinates of A. What are the coordinates of A? Just by looking at your function. Yeah.
A,
Mm-hmm.
-5. And -8.
-8. Why are we saying so? Because it is the turning point. And you can see already the values of the turning points there, right? Write down the range of F. So we need the range of this. What is this function doing? It is smiling, right? So it is having the what? The minimum point, right? And you say that if it is smiling like this, we say our range is y is the element of numbers, but our y should be what?
Greater.
Or
Less than.
greater or equals to?
Or equals to -8.
To -8. Why? Because -8, it is the y value of the what? The turning point. 3 marks for free. Calculate the values of m and n. Simple again. What is the value of m there?
-5.
The value of m is -5. So straightforward, you can say m is equals to -5, right? But can you find n? How? So remember, a function, what is a function? A function is the relationship between what? X and y. So once you have the x value of a point, you can find the y value using the function that defines that point. Because this point, it is falling on the what? Straight line, right? So if we substitute this value on this function, we can also find the what? The y value. Right? So always remember that as well. Right? So it means that our y becomes what? Becomes half of -5 plus what?
9/2.
Plus 9/2. So our y becomes -5/2 plus 9/2. So our y becomes what? It becomes what? 2, right? So it means that our m is equals to -5 and our n is equals to 2. Making sense? So every time that they ask you about finding the unknown, right? Check where that unknown is. If it is on a function, try to find if you're having another value of that point, and they substitute into the function that that point is falling in, right? And then they said what? Calculate the area of OCDE. OCDE, right? What is this? What is that? Something like a trapezium, right? How many marks are there? 3 marks. So what do you do if you're trying to find the area of a shape? So I don't know how you would have answered that, right? But according to the way that I would have done it, so we can see that OCD is a trapezium, right? So a trapezium, you can cut it into a rectangle and a triangle. Is that all? Okay. So we can cut this somewhere like that. Right? So what is the point of C? We hear that the C, it is that point. Am I correct? We hear that it is this. Because this is the y-intercept of this function, right? So C becomes 9 over 2, right? Right? But we know that this line, it is a straight line, it is a vertical line, right? So to find the distance of vertical lines, let me just show you here. So to find the distance of vertical lines, right? You subtract the y values, right? So what is the y value at C?
9
9 over
9 over 2.
Yeah. And then what is the y value here?
9 over 2.
Here.
That's 0.
0, right? So it means that now the distance between this and this, it will be 9 over 2 minus 0, right? So it means that the distance here is just 9 over 2. So it means that we know the distance there, right? It's 9 over 2. And to find the distance of horizontal lines, we subtract the x values. So what is the x value?
Negative 5.
Negative 5. So what is the x value there?
0.
0. So negative 5 is 0.
Negative 5.
But distance should be positive. So the distance here it is 5, right? So we know the distance there, right? What about the distance from here to here? This is also what? Vertical line, right?
Yeah.
So here the y value it is 2, right? And it is 0. So here the distance it will be 2, right? And then we also cutted this into something like this. So it means that the distance also from this point, let me just highlight that. The distance from this point to this point, it is just 2. The same way as this one, right? So this rectangle here, the area of this rectangle should be just 2 multiplied by 5, right? Because the area of a rectangle is length times breadth, right? So the area of the whole shape, it will be equals to length times breadth, right? Plus, what about the area of a rectangle, triangle? How do you find it? Half base times height. So the base becomes 5, right? And then the height becomes 9 over 2 minus 2. You get it, right? So it means that our area becomes 2 by 5 plus half of 5 by what? By 9 over 2 minus 2 is what? 9 over 2 minus 2. Is it not 5 over 2? It's 5 over 2, right? Yeah, because 9 over 2 is 4,5, right? So 4,5 minus 2 is 2,5, which is this, right? So this will give us 10 plus 25 over 4, right? So we can add that, and that will be our area of that. So whenever that you are given a shape, they say find the area, right? Try to check that area, that shape. If it is complex, try to break it into pieces, right? Okay. So they say determine the equation of the inverse.
You said for vertical line, you subtract the y values.
Is for vertical one, we subtract the y values, but for a horizontal one, the x values, right? And then determine the equation of G, the inverse. So you need the inverse, you know how to do the inverses.
Should I tell last year? This year I haven't watched charities.
Yeah, so let's see. So the inverse of a function. So this is g at x. We are trying to change that into g x, right? So on this function, we change y to be x and x to be y, right? So here it is y is equal to something, right? So I want to start that with x is equal to, right, half y plus 9 over 2. We can take this that side. So x minus 9 over 2 is equal to half y, right? Multiply everything by 2 so that you can be remaining with y, right? So it means that y becomes 2x minus 9. So that is our inverse. Right. Simple, eh? So they said h at x is equal to g at x plus k is the tangent of f. Determine the coordinates of the point of contact of h and f. What do we do? What do we do? So this is more of a calculus question. Should we attempt that or should we let it for calculus?
For calculus.
Should let it for calculus. Okay. Yeah, so this is more of calculus one, right? Okay. But it is not hard though. Okay, but let's just let it. Let's just let it. I don't want to confuse you. Okay, this is an exponential function. Let's leave it for now. But this one is using hyperbola on it. Won't it give you problems? I think this one we have to do hyperbola first. Let's just first find the ones with parabola only, or parabola straight line at least. Because straight line is not hard, right? Okay, just like this one. What can you see on this one? Oh, you know what? Attempt this question. And then we can do the corrections together. Where's the thing?